Hello friends, this is part 3 of solved question paper mathematical physics paper PHYC3A 2024 Dibrugarh University BSc 3rd SEM. So we have already solved question number 1 and question number 2. Okay, there are not only these two are not only two questions. Question number 1 consists more than one question. That means question number 1A, 1B, like that, and similarly 2 is also. So we have already solved in the first two videos question number 1 and 2. Today we're going to start from question number 3A, right? So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. that's my Insta ID. You can follow me on Insta. So now let's start. So this is the question number 3A1. So there are two differential equations, this one and this one. So now you see, if you want to score in differential equation, so here you can see you can score 7 marks from here. For that, you see, you cannot depend on PYQs only if you want to score in differential equations. So I have created a complete playlist, series of video lectures on this differential equations, because there are different types of differential equations, and there are different methods for different types. So these are already explained in detail. So I have given the link of the playlist of that differential equation in the description box. Please watch those video lectures and first go and watch those video lectures and understand. Otherwise it will be better if you don't waste time on differential equations. Okay, so if you are not lucky enough, then you can't get an equation that you can solve just you can solve in exam, just if you practice PYQs only. Okay, so because there are various methods and different types of differential equations, so if you practice only 2 and 3 examples, then you cannot solve those, okay, in exam. So that's why it will be better if you go through all the video lectures that I have given the link in the description box. Okay, I have given the link of the playlist of differential equations, so please watch those first. So now let me show you how to solve this. So first one is very simple. Okay, you can solve it by separating the variables. So first let me solve this one. So 4x plus 1 whole square dx dy, that means dy of x is equal to 1. So here it can be separated like this: 4x plus 1 whole square dx dy, and if you square it, then you're gonna get 16x square plus 8x plus 1, applying a plus b whole square formula, right, dy. Now let us integrate both sides. Okay, so integrating both sides, let me write here, integrating both sides. What we're gonna have, 16 is constant, x square dx, then plus 8 is constant, integration x dx plus 1 dx is simply dx, so integration of dx is equal to integration dy, right? And integration of dy is simply y, and we need an integrating constant, let it be c. And if you integrate this 16 into, we know that integration of x to the power n dx is nothing but x to the power n plus 1 by n plus 1. If we apply that formula, then what we're going to have, x cubed by 3, right, plus then 8 into x square by 2, here power is 1, right, and integration of dx is simply x, right? Hope you have understood this. So this is the required solution. So you can write this way: 16 by 3 x cube, and you cancel this 4 x square plus x plus c. So here is the solution, that's enough. Okay, so now let's solve this one. Okay, Now this equation cannot be solved by this method. Okay, so first let me write the equation in the next page, in the in the next slide. So here is the given differential equation that we need to solve. Now this equation can be written in this way also. Instead of d2 dx2, we can replace it by d square, and we can replace this by d. Okay, and doing so we're gonna write this in this way: d square minus 3d plus 2, and this operates on y. We can write that way. Okay, we can write that. So here you see, first we need to solve the auxiliary equation. Okay, auxiliary equation is, we should take this one, right? We should take this one. Let me copy this. Okay, and we need to make the right hand side equal to 0. Okay, that is auxiliary equation. Hope you have understood this. So now if you solve this, then you're gonna get, let me use the splitting middle term. Okay, is equal to 0. Hope you know this. This is quadratic equation, right? So d is taken common, d minus 2, and minus 1 is taken common, d minus, sorry, that's supposed to be 2, is equal to 0. And taking d minus 2 common, we're gonna get d minus 1 is equal to 0. So from here what we're gonna get, so d minus 1 is equal to 0, or d minus 2 is equal to 0. So which means d is equal to 1 and 2. So we have got two roots here. We have got two roots. Those are m1. Let me take this one as m1 and this one as m2. m1 is 1 and m2 is equal to 2. And these roots are real and unequal roots, right? So there are three different cases: real and unequal, real and equal, and imaginary. So for different cases we're gonna get three different complementary function, CF complementary function. So if the roots are real and unequal, the complementary function is given by c1 e to the power m1x plus c2 e to the power m2x. And if these are real and equal, then this CF will be different. Okay, so if you want to learn all these things, then please go through the course that I have made on differential equation. Link is in the description box. Okay, so now you see here, if you put the value of m1 and m2, what we're gonna get? E to the power m1 is 1, so let's put 1 here. Then 1 into x is x. c2 e to the power m2 is nothing but 2, right? Then twice x. Okay, you may consider 1 as m2 as 1 also. Okay, then that will be also correct. Okay, don't think that will be wrong. Okay, understood or not? So now you see, now we need to find the particular integral, pi, particular integral that will be given by so particular integral f of d is nothing but this one. This part is f of d. Okay, right? Hope you have understood this. Or you can say the left hand side of this auxiliary equation is nothing but f of d, right? F of d. Okay, now you see, f of d into e to the power ax, then this is equal to f of a e to the power ax. So here e to the power ax is equal to nothing but this one, this right hand side, e to the power 3x. Okay, so it is not necessary that in every equation you will get e to the power 3x on the right hand side. Okay, you may have different functions, and for different functions and procedure will be different. So please, that's why I'm requesting you to watch all those videos, okay, of differential equations, because I have already explained each and every conditions, each and every methods and rules related to this topic. Okay, So now you see, so here if you compare these two, then a will be equal to 3 now. And one more thing, this f of d is nothing but here d square minus 3d plus 2. So that's why pi, that will be 1 by f of, instead of a we're gonna put 3 and e to the power 3x, and that's gonna be equal to, and f of 3, this is nothing but f of d. If you find f of 3, that's gonna be 3 square minus 3 into 3 into 3 plus 2 into e to the power thrice x, right? That's what we're gonna have. So e to the power thrice x divided by, so 3 square 9, 3 is a 9, 9 minus 9 0, that's divided by 2, and therefore the solution is, y is equal to cf plus pi, and cf is c1 e to the power x plus c2 e to the power twice x, and pi is e to the power thrice x divided by 2. So this is the required solution. That's how we can solve. So hope you have understood this. So now let's move on to the next question. So here, using the Wronskian, we need to say, we need to check these two functions are linearly dependent or not. So how to check that? Suppose you have, let me explain the condition first. Suppose you have n number of functions, f1 of x, f1 of 2, okay, dot fn of x, fn of x, right? Then Wronskian, according to Wronskian, if the determinant of these functions, here is, if this determinant, if you take the determinant of f1 of x, f2 of x, dot up to fn, and in the next row if you take f1 dash of x, that means first order derivative of f1, similarly first order derivative of f2, dot again first order derivative of fn, okay, of x, and if you continue this way up to n minus 1 order derivative, f1 of n minus 1 order derivative of f1 of x, similarly if you continue up to f of n minus 1 order derivative of f of n, okay. And if this is not equal to 0, then if this is not equal to the 0, then these functions are linearly independent, okay. Now here you see, we have only two functions here. f1 of x is e to the power x cos of x, and f2 of x is e to the power x sin of x, right? So here Wronskian will be given by f1 of x, f2 of x. Then we're gonna take first order derivative. Here we're gonna end this taking first order derivative, because here only we have two functions. If we had suppose three functions, then we have to continue up to second order derivative as well, okay. For n number of functions, we need to take up to n minus 1 order derivative, right? But here we have two functions only, so we're gonna end this just taking a first order derivative, f2, first order derivative of f2, this. So now you see, first let me find first order derivative of f of x. So if you differentiate this, take u and v, derivative of first function, this this rule, this product rule of derivative, define derivative of first function into second, then first function into derivative of second, or you can write this way also, first function derivative of second and derivative of first function into second function. This way also you can write that rule. So now derivative of e to the power x is e to the power x into second function, that is cos x, plus then first function, that is e to the power x, derivative of cos x is minus sin x, so it's gonna be minus sin x, right? We have applied u into v rule. Similarly, we can find that first order derivative of f of 2, that's going to be equal to, again, e to the power x, its derivative remains e to the power x into second function sin x, then plus first function, that is e to the power x, derivative of the second, derivative of sin x is cos x, right? So that's what we have got. Now let us use this result here in this determinant. So let me clean this part. Okay, now you see. Okay, so what we have got here, let me write this one. First, f1 of x is this, right? Then f2 of x is this, okay. Then let me use these two results also. Okay, so now let's obtain the determinant. So how to obtain that? First, let us multiply this one and this one. Then what we're gonna have, so that's gonna give you e to the power x into e to the power x, that's gonna be e to the power x whole square, then cos x sin x plus e to the power x square, x whole square is taken common, then we're gonna get cos x cos x cos square x, cos square x, that's what we're gonna have, right? So it can be written this way, e to the power twice x, e to the power twice x into this, right, minus, now let's multiply this one with this, right? Then what you're gonna have, again e to the power twice x, then cos x sin x, then minus sin square x, that's what we're gonna have, right? So now you see here, if we take this common, right, then we're gonna end up getting, just give me a second. Okay, let me rearrange these things, just wait. Okay, let me write this one here. Okay, and let me write these things here, so I get enough space to explain this. So now you see, just let me write. Now if you take this common, e to the power 2x, then what you're gonna have, then this is taken common, e to the power twice x is taken common now, right? So then, and remove this bracket as well, then this minus will be plus, right? Hope you have understood this. So this is what we have done. We have taken e to the power 2x common, right? So brackets are open. Now here you see, now these two terms cancels, right? Now we have left with cos square x plus sin square x, that's gonna be equal to 1. So we end up getting e to the power twice x into 1, that means e to the power twice x, which is not equal to 0, which is not equal to 0. That means the given functions are, that means the given functions are linearly dependent, sorry, linearly independent, okay, right? So if we get the Wronskian is not equal to 0, then we can say these functions are linearly independent. So now let me answer the next question. So here is the next question, question number 3b1. okay, 3b1. So here it is given that z into x plus y is equal to x square plus y square. We need to prove this left hand side is equal to this right hand side. First, let us obtain partial derivative of z with respect to x. So how to obtain it? Now here you see this can be written this way: z is equal to x square plus y square, x square plus y square divided by x plus y. So here we're going to apply this rule that derivative of u by v, both are functions of x, suppose. In that case, denominator derivative of the numerator minus numerator derivative of the denominator by denominator square. Hope you know this rule, right? Hope you know this rule. So if we apply that, here the denominator is x plus y, right? So denominator derivative of the numerator is x square plus y square, then minus numerator, that is x square plus y square, derivative of the denominator, that is x plus y, right? Then divided by the denominator square, that is x plus y whole square. Now you see, if you differentiate this, that's gonna give you twice x, and we are differentiating with respect to x, that's why derivative of y square with respect to x, that's gonna be 0, as it is partial derivative, right? So here we can write x plus y into twice x minus x square plus y square, and if you differentiate x with respect to x, that's going to be 1, and if you differentiate y, that's going to be 0. 1 plus 0 is simply 1, so that's why we end up getting this, right? Hope you have understood this. Now you see, by denominator is square, x plus y whole square. Now what we can do here, okay, let me keep it this way only, del x of z. Okay, so now let's find, let us differentiate the z with respect to y. Let us differentiate z with respect to y. So let us differentiate z with respect to y. Again, if we apply the same rule, okay, but here we're going to differentiate with respect to y instead of instead of x, we're going to now differentiate with respect to y, right? Just give me a second. Let me copy this and just wait a second. So here you see, let me change this x only. Instead of this x, we're going to put y here, right? So instead of this del x, we're going to put del y here, right? So hope you have understood this. Now you see, if we differentiate, what we're going to have here, x plus y, this time we're going to get twice y, as we are differentiating with respect to y, and x square plus y square divided by x plus y whole square. That's what we have got. So this is derivative of z with respect to y. Now let me copy this results. This is equation number 1, suppose this is equation number 2. Okay, let me take a new slide. Okay, let me copy these two equations. So we're going to use this. This is the first equation, and the second equation is this. This is the second equation, right? So let me rearrange this so that I can utilize maximum space in the same page. So now you see, if you see, the equation that we need to prove is this: del z del x of z minus del y of z whole square is equal to 4 times 1 minus this, right? Okay, we need to prove this. So let me copy this one as well. Okay, let me write here. This is what we need to prove. Okay, first let us find the left hand side. Okay, so first, equation number 1 minus equation number 2, to obtain the left hand side, let me subtract these two, equation 1 and 2. Okay, so then what you're gonna have, you see, you're gonna get del x of z, let me write here, minus del del z of y. Then if you subtract these two right hand side, then this will be the denominator, that will be the LCM, x plus y whole square, right? That's going to be the LCM. And then you're going to get this one here, you see this one minus this one. This one you're going to get, right? So if you subtract, then this minus sign will be plus, right? Hope you have understood this, right? These two will be cancelled, and from here we can take this common, right? X plus y can be taken common. So if we take x plus y common, then within bracket we're gonna left with 2 into x plus sorry, not plus, there will be minus 2 into y divided by x plus y whole square. Again you see this one will be cancelled, right? So 2 can be taken common, so we end up getting x minus y by x plus y. That's what we're gonna have. Now the left hand side, here we have whole square. So if we square both sides, then this one whole square, then this one will be again whole square. So that means to obtain the left hand side, let me bring this one here. Just give me a second. Okay, just give me a second. Okay, so now left hand side, let me write the left hand side. Left hand side is equal to, let me copy the left hand side here. Okay, so this one gonna be equal to square of this result, right? This part is this one, right? And this is equal to this. So what we can write, we can write 2 x minus y by x plus y whole square, and that's going to be equal to nothing but, that's going to be equal to nothing but this square of 2, that's going to be 4, and we can write this way. Okay, that is what we're going to have. Now let's find the right hand side. Now let's obtain this right hand side. Let us evaluate this. Okay, now you see, now okay, let me just give me a second. First pause the video and note what I have written till now, because I'm gonna clean this part, okay, as I have not enough space. Okay, now you see, so I'm gonna keep the result only. So let me cut this, let me keep this result only, okay, because I'm gonna use this result. Okay, so now you see, let's obtain the right hand side. Right hand side, here you can see this is the right hand side, this is the right hand side. Okay, just give me a second. Sorry, so here is the right hand side. So let me evaluate this. So here you see, if you take this minus sign common, then what you can write, instead of doing that, let me do one more thing. That's right hand side gonna be equal to 4 times of 1 minus, so what was the value of this one, right? Okay, this one, if you use this value here, minus, just give me a second, minus, what is the value of this del del y of z, that is this. Let me use this one here. Okay, so if you use that, sorry, if you use this result here, then you're gonna get this. Okay, here is the minus sign. So now you see, you can take this LCM, right? So now let me cut this one. If you take LCM, then what you're gonna get, 4 into then x plus y whole square, then if you multiply with this 1, then you're gonna get x plus y whole square minus, after taking this LCM, then this minus is here actually, this minus will be plus, okay, x plus y twice x plus x square plus y square. Then here, because of this minus will be changed after taking LCM, then again here we're gonna get minus x plus y into twice y, this minus will be plus x square plus y square. That's what we're gonna have. Now you see what we are getting here. I hope you have noted all these things. Let me clean this first. Okay, now you see this is the left hand side and this is the right hand side. Here the bracket should be closed. Okay, so this is what we have got now. Okay, so hope you have understood this. Now let us simplify. Here you see, if you add this 2, then you're gonna get 2 of x square plus y square. So let me simplify here directly. Okay, so instead of writing this 2, let me put this here. This is what we have got. Okay, now you see, if you take this x plus y common from these two terms, okay, then this minus x plus y is taken common. Then if you take the minus sign common within bracket, you're gonna end up getting twice x plus twice y. And again, if you take 2 common, then here you see, then you're gonna get this minus 2 of this. And if you multiply these 2, then what you're gonna get? You're gonna get this, right? So instead of these 2 terms, what we can write? We can write this way. Let me write here. Let me continue here, the right hand side. That's going to be equal to 4 into x plus y whole square, then minus. So from these 2 terms, on taking x plus y and minus 2 into x plus y is taken common, and within bracket we have got again x plus y. And product of these 2, we're gonna get x plus y whole square, x plus y whole square, and plus again we have got 2 x square plus y square. That's what we have got, and divided by x plus y whole square, right? Hope you have understood this. Now you see, okay, now if you subtract these 2, then what you're gonna get? 4 minus x plus y whole square plus 2 x square plus y square divided by x plus y whole square. That's what you're gonna get. Now you see, if you simplify this numerator, then you're gonna get x minus y whole square. Let me show you why. Let me show you how. You see, minus x, let me show you here, minus x plus y whole square plus 2x square plus y square. Now you see, if you expand this term, then you're gonna get minus x square minus 2xy minus y square, because we have minus here, right? Then plus 2x square plus 2y square if you expand this. Now you see, if you subtract this 2, then you're gonna get x square, and subtract this 2, then you're gonna get y square, and here we're gonna get minus 2xy, which is nothing but x minus y whole square, x minus y whole square, right? So we can replace this numerator, by x minus y whole square. So let me write this here, just give me a second. Okay, that's right. You see, let me continue. Okay. So from this step, just you write this step, okay, and from here I'm going to continue from here. Okay, so this right hand side will be equal to 4 into, and now the numerator becomes x minus y whole square, by denominator is x plus y whole square. This is nothing but 4 into x minus y by x plus y whole square, and this is equal to the left hand side. You can see, right, this is equal to the left hand side. So that's why it is proved. Okay, hope you have understood this. So now let me solve the next question. So this is question number 3b2. I have given the link, or given a link of a video. I have written to 3b2, and then I have provided a link here in the description box, where I have explained how to determine the link and what's that video. Okay, so what is the next question? Let's see. So here you see, either you need to solve these two questions, either b1, you need to solve b1 and 2, or instead of b1 and 2, instead of b1 and b2, you need to solve this. Okay, because this here you see, for this question 6 marks is given, and these two questions, for these two questions 3 and 3 marks given here, 3 for this question and 3 marks for this question also. So either you need to solve these two or solve this one. So I'm going to show you this one as well. Okay, this is question number 3b or. Okay, question number 3b or. So here you see, what are constraint maxima and minima. So here is the definition. Let me explain the meaning. So now you see here the example, to understand this we can take the example of this question. Here you can see, find the maximum value of this. So here we have a function, we need to find the value of this, and you know there is a condition, that is that you can say constraint. Constraint means you can say restriction, which is in the form of equation, or it may be sometimes inequality. Okay, so when a condition is given, when there is a restriction, or you know a condition, restriction, or you can say constraint is given to restrict the values of the maximum and minimum, then we used to say constraint maximum or minimum. Okay, now let me solve this problem with this question. Here you see, what we need to do, find the minimum value of this. Okay, subject to the condition x, y, z, aq. So now let me find that. Okay, let me take a new slide. First let me write the function f of x comma y comma z. That function is here, x square plus y square plus z square. Then we have the condition x, y, z, which is equal to a cube. Now you see, this condition can be written this way, x, y, z minus a cube is equal to 0, and you can compare this one with this, phi of x comma y comma z is equal to 0. If you compare with this, then you're gonna get here phi is equal to x comma y, x, y, z minus a cube. This is equal to phi, right? Hope you have understood this. If you compare this one with this, right hand side is equal to 0, right? Now what we're gonna do, we're gonna take this derivative of f with respect to x, partial derivative, plus lambda into derivative of phi with respect to x is equal to 0. Okay, similarly, okay, just give me a second, let me clean this part. Hope you have written this definition. If not, then pause the video and note it. Okay, so now you see, let me copy these things and let me write these things here. Okay, then we're going to take this equation, derivative of f with respect to y plus lambda into partial derivative of f with respect to, partial derivative of phi with respect to y is equal to 0, and next equation we're going to take partial derivative of f with respect to z plus lambda into partial derivative of phi with respect to z is equal to 0. Now you see, if you differentiate this f with respect to x partially, then what you're gonna get? Here you're gonna have twice x, right? Twice x, and derivative of these two will be 0 with respect to x, then plus lambda. And if you differentiate this phi with respect to x, then you have to take y and z as constant. Then you're gonna get derivative of x with respect to x, that's gonna be 1. So 1 into yz is yz. Then derivative of a cube, that's gonna be 0, right? That is equal to 0 here. And from here you're gonna have x is equal to minus lambda yz divided by 2. That's what you're gonna have, right? If you simplify this equation, right? Hope you have understood this. So similarly, if you solve this equation, then you're gonna have y is equal to minus, when you had x here, you have got y and z, and when you're gonna have y here, then you're gonna have x and z divided by 2. Similarly, this one gonna be equal to, this one implies z is equal to minus. So when you have z here, then here you're gonna have y and x divided by 2. That's what we're gonna have, right? Hope you have understood this. And if we use these values here, you can see okay, what we're gonna do, we're gonna put these values in equation number 1. So let me give, this is equation number 1, this is equation number 1. Now putting the values of x, y and z in equation number 1. So if you put those values, instead of x, if we put minus lambda, so here you see, instead of x, let us put minus lambda yz by 2 into, instead of y, we're gonna put this value minus lambda xz by 2, and instead of z, we're gonna put this value of z, that is minus lambda yx by 2 is equal to 0. And if you simplify this, what you're gonna have, I forgot to write the a cube here, minus a cube is equal to 0. And from here what you're gonna have, minus lambda cube by 8 x square y square z square minus a cube is equal to 0, right? That's what you're gonna have. Now you see, minus lambda cube by 8, this x y z whole square minus a cube is equal to 0. This implies, what does it imply? Lambda cube by 8. Now you can replace this x y into z by this value, right? That is a cube whole to the power 2, that's gonna be a to the power 6, that's gonna be a to the power 6, right? So here a to the power 6 minus a cube is equal to 0. Since x y z is equal to a to the power 3, right? We have used this value. Okay, now you see, and if you simplify this, what you're gonna have, let me just give me a second. Okay, so if we simplify this, then what we're gonna have, here you see, if you divide both sides by a to the power 3, then you're gonna have lambda cube by 8 into a to the power 2 minus 1 is equal to 0, and that will imply, yes, that's correct. So that's gonna give you, just give me a second. If you divide both sides by a cube, then you're gonna get here a cube. Okay, a to the power 6 divided by a to the power 3, that's gonna be a to the power 6 minus 3, a to the power 3. So So minus 1 equal to 0, and if you simplify this, then you're gonna get this is equal to 1. Okay, and again if you simplify this, then you're gonna end up getting lambda cube is equal to 8 by a, you can write minus 8 by a cube, right? Minus 8 by a cube, and it can be written this way, 2 by a minus 2 by a whole cube. It can be written this way. That means lambda is equal to, from here you're gonna get lambda is equal to, this is whole to the power 3. Okay, lambda is equal to minus 2 by a. So we have got the value of lambda a. Okay, so now let me take a new slide. First let me copy this equation number 1. Okay, just give me a second. So here is the equation number 1, and let me copy this results. Okay, so let me put this one here. Okay, then let me use these two results. Just give me a second. Okay. And we have got lambda is equal to minus 2 by a. Right, so now what we're going to do here, you see, we're going to put let me take the given function. This is f of x comma y comma z. Okay. After getting all those values, now what we're going to put, let's put x square. So now you see x square from this this equation, from this equation, what we're gonna get from this equation, you can see this can be written this way also, x is equal to minus lambda, this yz can be replaced by yz will be equal to a to the power 3 by x, right? Okay, so we can replace from this equation, you see yz, if you simplify this, you're gonna get that gonna be equal to a cube by x. So we can replace this yz by a cube by x. So here we're gonna get twice x, right? So and this x into this x, that's gonna be x square. So we're gonna get x square is equal to this, right? So you can write here using 1. Similarly, and from here you're gonna get y square is equal to lambda a cube by 2, and similarly you can replace this y by x also, a cube by z, and then you're gonna get this z square is equal to minus lambda a cube by 2. That's what you're gonna have, right? Hope you have understood this. Let me write it properly, minus lambda a cube by 2. Okay, now let us put this x square, y square, z square here. Okay, then lambda a cube by 2 minus lambda a cube by 2 minus lambda a cube by 2. That's what we're gonna have. Now adding these two, we're gonna get adding these 3, we're gonna have minus 3 lambda a cube by 2. Now what is the value of lambda? Let's put the value of lambda. Value of lambda, we have got this, right? Minus 2 by a, okay, into a cube by 2 here. So this 2 cancels, this minus minus, it will be plus, right? Then we end up getting this a cancels a cube, gives a square. So we're gonna have 3a square, 3a square. So this is the minimum value, right? So this is the answer. So hope you have understood this. So now let's solve the next question. Now this is question number 3c. Okay, 3c1. Either you need to solve this one or this one. I'm going to show you both. So here we have a function, and we need to find the directional derivative at this point, okay, in the direction of this vector. So how to find that? Now you see First, you see, first take this note, directional derivative, okay, of phi, which is function of x comma y comma z, okay, along a vector d is given by gradient of phi dot d cap. Okay, gradient of phi d cap. So now here you see, in this problem here, this phi is x square minus twice y square plus 4z, and the d vector is 2I cap plus j cap minus k cap. First, let us find gradient of phi, and gradient of phi is nothing but del x del y, sorry, let me write here, del x I cap plus del y j cap plus del z k cap of phi. Phi is nothing but x square minus twice y square plus 4z. Now how to find the gradient here? Now you see here, if you differentiate this with respect to x, then what you're gonna get? You're gonna get twice x, and here we have I cap, so twice x I cap. Then if you differentiate this with respect to y, so this is gonna be 0, this is gonna be 0, then you're gonna get minus 4y. If you differentiate minus 2y square, then you're gonna get minus 4y, and we have j cap here, so it's gonna be j cap. And similarly, if you differentiate this with respect to z, then you're gonna have plus z only, sorry, 4 only, the derivative of z with respect to z, that's gonna be 1, right? And we're gonna have k cap here. That's what we're gonna have, right? Hope you have understood this. Now you see here we have, sorry, I made a mistake, there was 4z square, okay, 4z square. If it is 4z square, then it gonna this gonna be 8z k cap, right? Now let us obtain d cap. D cap means unit vector of d. Okay, so let me draw a red line here. So I'm going to continue from here, you can see. So d cap, that's going to be equal to d vector divided by magnitude of d, right? So d vector is here, this is the d vector here, you can see, this is the d vector, right? And its magnitude going to be root over 2 square plus 1 square plus minus 1 square. So that's going to be equal to, this d vector divided by root over 2 square is 4, 1 plus 1 6. So that's what we're going to have, right? So hope you have understood this. Now we need to find the grade phi dot d cap, right? So grade phi dot d cap. So grade phi, we have got this, right? So this is grade phi, gradient of phi, this one, dot d cap. D cap is this one here, you see, this is d cap, right? This is nothing but d cap. Okay, so now if you find the dot product, then hope you know how to find a dot product. So 2x I cap dot 2I cap, that's going to be 4x. Similarly, minus 4y dot j cap dot j cap, so that's going to be minus 4y. Then 8z k cap dot minus k cap, that's going to be minus 8z, right? So we need to find the directional derivative at this point, at 1 comma 1 comma minus 1. At this point, let's put the value of x, y, z respectively 1, 1, minus 1. Okay, so then here at this directional derivative of phi along or in the direction along this vector 2I cap plus j cap minus k cap is equal to 4. X is 1 here, minus y is also 1, minus z into z is minus 1. Okay, 8 into minus 1 by root 6. Now if we calculate this, then what we're gonna get, so these two will be cancelled, plus minus gone, so we're gonna have plus 8 by root 6. So this is the answer, right? Hope you have understood this. Now let me solve 3C1 or okay, this one. Okay, let me solve this. So first pause the video and note these things, and let me clean this page. Okay, now you see, let me clean this page. Okay, just give me a second, just wait. So here we have x y cube z square is equal to 4. Okay, and we need to find the unit normal to the surface. This is the surface. So if we compare with this, let me give you a note here. So now you see, normal to the surface, normal unit vector, normal unit vector. First let me write simply normal vector to the surface, you know, phi, which is a function of x comma y comma z, is equal to c some constant. Okay, is given by gradient of phi, okay. So now we're gonna apply this, right? So here if you compare this one with this, so here you're gonna get phi is equal to x y cube z square. Now let us find the gradient of phi. First you should differentiate this with respect to x, then what you're gonna get, y cube z square, then I cap, plus differentiate this with respect to y. First let me write this, okay, instead of doing this way, del x I cap plus del y j cap, that is the del operator, del z k cap. Phi is here x y cube z square. Okay, so now first differentiate this with respect to x, so y cube z square I cap, then operate this one by this operator. So we're gonna have 3xy square z square j cap, then with respect to z, what we're gonna have, 2xy cube z k cap. That's what we're gonna have, right? Now you see, let me continue here. Okay, so this is what we have got. This is normal vector, so now at this point, at the point what is the point, -1 comma -1 comma 2, at this point what we're gonna get, the normal vector is, if we put here -1 and 2, then we're gonna get -1 cube 2 square, that's gonna be -4, right? -4 I cap, -4 I cap, right? Now let's put here -1 y square that's going to be minus 1 square, then z square is 2 square. So 2 square is 4, so here we're going to get 4 3s are 12, right? There is 3, so 12 z cap. Then okay, so this is minus 1, this is minus 1 square, so it's supposed to be minus, right? Now you see, and here if we put the values of x, y and z, then again we're gonna get minus 1 minus 1 cube, then into 2, that's gonna be 4 k cap. 4 k cap, that's what we're gonna get. Therefore normal unit vector is, so we're gonna take this vector and we're going to divide it by its magnitude, that is minus root over minus 4 square, root over minus 12 whole square, then plus 4 square. Okay, then what we're going to get if we calculate all this, if you calculate these things. So just give me a second, let me erase these things. Just let me erase the note. Hope you have written these things. So let me write these things here. Okay, now let me continue. Okay, now if we calculate this, what we're going to have, minus 4 is taken common, then I cap plus 3 z cap, then minus k cap on taking minus 4 common, and here under root we're going to get 16 plus 144 plus 16 again, and if you add these numbers, then you're going to get 176, right? And it can be written as 16 into 11. This can be written as 16 into 11, and square root of 16 is 4, so we can write this one as this 4 into root over 11, 4. So 4 gone, so we end up getting minus 1 by root 11 into I cap plus 3 z cap minus k cap. This is the answer, right? Hope you have understood this. Now let me show you the next question. Here you see, so I have already made a video on this. I have already solved this question. I have given the link in the description box. I have written question number 3C2 and I have given the link, okay, in the description box. So in the description box you're gonna get 3 links. One is question number 3B2, and for 3C2, then one for differential equation. Okay, one for differential equation. You're gonna get 3 links. So hope you have understood this. Thank you for watching. See you in the next video. Bye bye.